Uh, in this section of measuring and expressing enthalpy changes, the heat that is absorbed or released during many chemical reactions can be measured by techniques called calorimetry. In a chemical equation, the enthalpy change for the reaction can be written as either a reactant or a product. You can measure an enthalpy change by determining the amount of heat involved in a reaction.
Avery. Okay. So vocabulary for 17.2, one of them is calorimetry, and it means it measures heat flow in and out of the system for chemical and physical process. Second definition was calorimeter, an insulated device that measures endothermic or exothermic heat in chemical or physical processes. Another definition is enthalpy. Enthalpy accounts for heat flow and constant pressure of the system. Thermochemical equation. It's an equation that includes the enthalpy change. Heat of reaction is enthalpy change for the equation. Heat of combustion. Reaction of heat for complete burning of a mole of a substance.
How can we measure the change in enthalpy of a reaction? The value of delta H of the reaction can be determined by measuring the heat flow of the reaction at constant pressure. How can you express the enthalpy change for a reaction in a chemical equation? In a chemical equation, the enthalpy change for the reaction can be written as either a reaction or a product.
Calorimetry is the science or act of measuring changes in states, variables of a body for the purpose of deriving the heat transfer associated with changes of its state due, for example, to chemical reactions, physical changes, or physical transitions under specific contrast. Calorimetry is performed with a calorimeter.
In this sample problem, it's asking us to calculate the amount of heat in kilojoules required to decompose 2.24 moles of NaHCl3, and our equation for this problem is 2NaHCl3 plus 85 kilojoules yields to Na2CO3 plus H2O plus CO2. First, you want to list your knowns and your unknowns, and our knowns for this problem is delta H equals blank kilojoules for 2 moles of NaHCl3, and the amount of NaHCl3 that decomposes equals 2.24 moles. And our unknown is delta H equals blank kilojoules for 2.24 moles of NaHCl3. Our conversion factor for this problem is kilojoules to moles of NaHCl3, and 85 kilojoules are needed to decompose 2 moles of NaHCl3 according to the equation. So we want to start off with 2.24 moles of NaHCl3, and we want to multiply that by our conversion factor, which is 85 kilojoules over 2 moles of NaHCl3. And we want the NaHCl3s to be on the bottom so that they'll cancel out. And when you multiply 2.24 by 85 and divide that by 2, and you get 95.2 kilojoules, which is our answer. So delta H equals 95.2 kilojoules. In this sample problem, our problem is a small pebble is heated and placed in a foam cup calorimeter containing 25 milliliters of water at 25 degrees Celsius. The water reaches a maximum temperature of 26.4 degrees Celsius. How many joules of heat are released by the pebble? So in this problem, Q means the heat energy, volume is volume, C means specific heat, and delta T is the change in temperature. So for this problem, it's asking us what the joules of heat is released by the pebble. Our volume is 25 milliliters. Our specific heat of water is 4.18 joules per grams times degrees Celsius. And our delta T, our change in temperature, we want to subtract 25 from 26.4, which comes from our problem, and we get 1.4 degrees Celsius. So to start off this problem, you have the equation Q equals MC delta T, and then you just want to plug in your stuff. So Q equals 25 times 4.18 times 1.4, and the answer you get is 146.3 joules are released.